we might come into a place that's been running along for 10 years with way more stuff running than needs to run because there hasn't been good visibility. And like I said, it's a complicated system. And maybe, you got a room with 40 big, noisy, power-hungry machines, and they just run them all because that works, And then, our software comes in and it's super smart and it's looking at everything minute by minute and figuring out what really needs to run and what doesn't. And it turns a bunch of stuff off. And we've had kind of interesting, like legit concerns. Like somebody runs into the room, where's the Vigilent guy? Right here. It's too quiet in there.
Welcome back to the Decarb Connect podcast. As many of you know, I often focus a lot on hardware technology or the kind of big engineering solutions, and I'm actually really excited today to take a totally different lens. So I'm here with Cliff Federspiel, who's the president, CTO, but probably most importantly, co-founder of Vigilent, and we're going to be talking about AI and its role in reducing CO2 and a variety of other benefits as well. So Cliff, welcome. Thank you very much for agreeing to come and have a chat with me about something that we hear a lot about, and AI gets, it feels like there's always stories about it, a very mixed level of understanding about it. So I'm very grateful to have you here. Perhaps you could start by just giving us a feel for how you've arrived at this point in time where obviously you're AI, but you're at this intersection with climate. So how did that come to be?
Yeah, well, thanks for inviting me, Alex. It's great to be here. My focus and interest in AI and climate goes back a long ways. I had 3 degrees in mechanical engineering and finished my graduate work at MIT. And the subject of my research was, in fact, the sort of intersection of AI and control engineering. AI is actually, it seems new to a lot of people, but, AI is a decades old science. It goes back to, the 1950s and 60s, really. And so when I was at MIT, there was a lot of activity actually in integrating AI concepts with more traditional process control concepts. So I wasn't the only student working on this. And in the application area for my PhD was HVAC. So, I've been basically doing this since I was a graduate student. MIT is a really entrepreneurial place. So I got kind of intrigued by the idea of starting a company. There's a whole bunch of, super well-known startups that have come out of MIT. But, as a grad student, I had no idea, right? So, when I left MIT, I decided to go get some industry experience first. But, I was also interested in some academic experience, maybe being a professor. So I took an academic position at UC Berkeley and did a bunch of research on applications of wireless mesh networks. That's a mouthful. Mainly applied to building control and building monitoring and things like that. And that was so that was like early 2000s, and that was the time where there was starting to be like really more and more acute awareness of the global energy and carbon emission problem. So I sort of felt like at that point in time, that was sort of the aha moment. There's this huge global problem around energy and environment, and these technologies that I had a lot of deep experience with, AI and wireless mesh networks, and it just seemed like a good opportunity to put them all together and start up a company. So we did that, and we've been doing that, for a number of years now. We incorporated in 2008, and it's been a great opportunity to make an impact. But for me personally, my wife and I have been casual scuba divers, since we were young. And, recent dive trips we've been on, you can really see the difference in coral reefs from what it was 20 to 30 years ago. It's kind of sad, honestly. They just don't look as vibrant as they used to. Wildfires in California, we're in California, and wildfires have become just this major thing every year, and it just start earlier and earlier. just all of these things are, areas of that, for me personally matter, that are related to, the environment and what energy consumption is doing to the environment.
Yeah, I think what's interesting is that so many people feel those things, sense those things, but either they aren't, they don't have, in your case, the very technical expertise that they could lean into, or maybe just don't know that they really have it in them to make that change and to be part of that change. So it's kind of interesting to hear that story of how you built this body of knowledge, but you also have the personal driver as much as that professional driver. So let's then have a look. We've got that as our context in terms of your
Yeah.
context in this. Talk to me about you have HVAC was part of your background. You have
Yeah.
this deep technical experience and understanding of AI.
Yeah.
You could still have applied that in a million different ways. So how was it that the kind of the focus and the business of Vigilent came to be? Like, what was it about this particular part of the market?
Yeah. So AI as a technology is really good at addressing complex systems. I mean, you just look at, the AI that everybody's talking about these days is focused on, for example, language, right? And creating language. I mean, language is a really complicated thing, and AI, as we all know, is really good at language problems and modeling language. It's good at lots of other. I mean, it's just a general purpose way of modeling systems, and so it's good for lots of other complex systems. Um, the reason for focusing on HVAC is because, frankly, I knew a lot about it, and like I said, it's a type of system that's very energy intensive. So it's a thing that is contributing to the global problem that we're facing around energy and carbon. Um, so, so that's why sort of the intersection of AI and HVAC. We didn't actually start the company though focused on data centers, which is where most of our activity is. We started focusing the company on old buildings, legacy buildings that are super inefficient, and trying to use AI and wireless mesh networks to make them as, honestly, about as efficient as a modern code compliant building. We got great results doing that, but it seemed like that was going to be a harder area to build the business. So from a business point of view, that wasn't really the best vertical to go after. And after we had gotten that going, data centers were just taken off, and the rate of energy consumption growth in data centers back in like the 2007 timeframe was so high that the government was investing in research and development and just quantifying it. There were reports coming out of places like Lawrence Berkeley National Lab on how acute the problem was and forecasts of where we'd be if we didn't do something about it. So we did, like lots of startups do, we pivoted, and we went from old legacy office type buildings to data centers. So, it's a combination of a big problem, a technology that's well suited to the problem, and, the business driver to, focus on that right area. And to be honest, like the data center, control and optimization problem is even more complicated than the office building one. There's more machinery, there's more interactions that are complicated. And so AI is frankly an even better technology for controlling data centers than it is for controlling office type buildings.
So, I mean, I'm sure most people listening to this know that data centers have this huge, as you've just said, huge energy footprint. And of course, all of us probably read frequently about, depending where you live in the world, in the UK, there's been quite a lot of press about, yes, we need data centers and some excitement about that, but then anxiety about the draw on energy. But probably beyond that, we don't know a lot about what some of their challenges are when it comes to energy use and the associated CO2. So can you just give us some of the stats? I have all the stats in
Yeah,
the world about industrials, less so on this. So just give us the stats and some of the challenges that clients bring to your door.
right. So data centers continue to use more and more energy. I think the latest stats are that about 3.5% of global energy consumption is by data centers. I believe that the data center industry contributes more carbon emissions than the airline industry. It's a very energy intensive thing to run a data center. It's getting more and more so. As far as the challenges that the industry faces, I think it's like a lot of other industries. There's a lot of constraints that are limiting growth, making it hard. There's not enough people. There's a massive staffing shortage in the data center industry. Finding people that are well qualified to run complex systems that absolutely have to always be up. Uptime is essential. There's not enough power. The growth in big AI, things like ChatGPT, these giant AI models, and training those is driving the demand for really big data centers. It used to be everybody was building 3, 5, maybe 10 megawatt data centers. These days they're building 50 megawatt data centers, 100 megawatt data centers. 100 megawatts is enough to power a whole city. And they want to put that into, just a small set of buildings running a bunch of computers. It's a tough thing. And then, capital, data centers are expensive. 100 megawatt data center is like, billions of dollars. And then the other thing is water. Data centers consume a lot of water. And it's sort of a weird thing. Water, the cost of water isn't that high. So even at the rate they consume water, it's not really a operating expense that's a big deal, but they consume so much water that they can like drain aquifers and change the local ecosystem. It's a really big environmental problem, even though it's not really as big of a cost problem. It's kind of a strange thing, really. So yeah, those are the things that are affecting the data center industry. Some other things to keep in mind. So we talked about the power consumed by these new bigger data centers, but there's been some other good examples of that has been a factor for Vigilent's growth. So for example, the great earthquake in Japan. We do a lot of business in Japan. The great earthquake in Japan, of course, caused the Fukushima disaster, and that caused the Japanese public to lose confidence in nuclear power. So they shut off, I think it was 50 of their 52 nuclear reactors. And that meant that in the summertime, they didn't have enough power anymore. So there you have a different kind of power constraint where the whole grid is constrained, and they have data centers and lots of other facilities that could be running more efficiently that aren't. And if they did, they'd have less of a problem with running out of power in the summertime and having to, live with rolling blackouts in order to accommodate it.
Okay, well, that's a useful kind of overview. Let's kind of make it a bit real. Let's see if we could use a project that you've worked on to sort of have a look how you've worked with a client, like what actually had to happen for them to have success with you. Who could you point to, or what kind of project could you use just to sort of bring that to life?
Well, Verizon has been a big and long-standing customer for Vigilent for a long time. We did a set of tranches of installations in Verizon data centers over the years. And one of the early tranches that we did, we went into, I think it was 16, but the first tranche was 16 of their big data centers, and then another, I think 22 or 24 of them. So the way this works, we come in, we install the wireless telemetry that needs to be in there, attach little wireless devices to the air conditioning equipment that's in the data center, get that set up, configure the software. All that takes maybe a week or two. Then we let it run for a little while, turn the control on and run it for some more time. And you can see a dramatic difference in, the amount of power consumed by those air conditioners that are under the control of the Vigilent system. So we did this in these tranches of Verizon data centers, and it had a really dramatic impact on their corporate efforts to reduce carbon. I mean, it was a significant fraction of their entire corporate goals for those years. So much so that they actually gave us an award for, the level of carbon reduction and energy efficiency that we were able to create for the corporation. I think that's a really good and successful, and it's one that we've been able to talk about. You can find out about that if you just go to the Vigilent website.
I just want to take this opportunity to thank our production partner and sponsor, Jano Media, for their support in delivering the Decarb Connect podcast. Over the last few years, they've helped us to facilitate great conversations that connect us with our audience, and their skills and expertise mean that we get to concentrate exclusively on generating the content, the conversations that engage, inform, and inspire. Well, look, when we think, or if we go back a decade or 2 decades and people were talking about big tech rollouts, ERP and the rest, there was never any concern about, the boundaries or where that technology go, because it didn't have that element of, intelligence to it. So when you think about applying this kind of technology in that data center environment, what's important about the kind of safeguards, the setup, the approach?
That's a super good question. So there's a number of factors related to this, right? So, for Vigilent, we're going into mission critical facilities, and I suspect that every industry pretty much figures that they're mission critical, right? I mean, process industries, if the process stops, they're not making money. That's a mission critical problem. And so it's the same in data centers. If the data center stops, money isn't being made, customers are really unhappy. So there have to be safeguards to ensure that, like, no matter what you do in a data center, that you don't cause a problem that could cause a service interruption. And then when you add AI onto that, that just adds sort of an additional level of concern, because people, frankly, there's concerns about AI, like, what's it going to do and why is it going to do what it's going to do, and how do I keep it under control and all that. So what we've done is build behaviors into the software and the hardware that protect against bad things happening. So at the end devices, the little wireless devices I told you we install on the air conditioning equipment, there are fail safes built into that. So if that little end device doesn't get a message from the control software, it will revert to a behavior that isn't efficient anymore, but it's safe, keeps everything still running. The servers don't get hot, everything's fine. And then in the software, we have behaviors. So we have a behavior we call guard mode. So if the optimizing behavior of the software isn't keeping the temperatures where they need to be, even when it's doing what it's doing, that can trigger a behavior we call guard mode, where we bring on more and more equipment, even though it isn't efficient to do so, until the problem corrects itself. And of course, that switching to that mode triggers an alarm, so people get notified about it, and they can, if an operator needs to do something, they can go do that. There are lots of other alarms. There's high temperature alarms, and all kinds of alarms are related to the functioning of the software. If there's a communication glitch or something like that, alarms will be triggered. And then finally, the thing is under the control of the operator. So there are both hardware and software manual overrides that allow operators to, make the system do their bidding, so that they're not, it's not a thing where the AI is going to run amok. They can always stop it from doing whatever it's doing, even if it's doing the right thing and they just don't understand it, or they need it to stop doing that because they got to do some maintenance or whatever. They can, assert manual overrides over it. And then when it comes to the AI and the machine learning, we have behaviors built into that prevent against some of the things that people now understand can happen with AI. So everybody that has been hearing about generative AI knows that it can hallucinate, and that's potentially true of Vigilent AI as well. So what we've done is build machine learning behaviors into our machine learning algorithms that help defend against hallucinations and the AI learning the wrong thing or doing the wrong thing. And that comes really in sort of two forms. So there's this concept in AI and reinforcement learning where sometimes the AI explores its control space, the things that it can do, the actions that it can take. Most of the time, it tries to optimize, right? So it exploits what it knows in order to optimize the process. But every now and then, it explores. The kind of textbook way of doing this is for a small fraction of the time, it will take a random action, right? That's how like the AI that plays video games works. You can't do that in a data center or frankly, any other industrial process, right? You can't just randomly do something in the hopes that you might learn something that's useful later. So what we have is exploration that's smarter than just random. So we have rules that govern how that's going to happen. We have analytics that figure out whether or not it even needs to explore, or maybe there's already enough information there for the machine learning to produce good models. So we have smarter than random exploration. And then the other thing we have is we have the ability to use prior knowledge. Like it could be some other information that we know from some other data center or from some other type of model to start the model up and give it a good starting condition to work from, so that this whole problem of that everybody is familiar with now of hallucinating AI is very unlikely to happen. But if it does, there's all those protective behaviors that we just talked about that keep things under control.
So I remember when we had our prep call, the parts of this that I naturally find the most interesting actually is the human and technology interaction. I think it's because way back in the mist of time, I had a sociology background, but we talked a little about the kind of the boundaries, if you will, the way that you manage how the tech learns and behaves and so forth.
Yeah.
And how do you ensure that organizations actually have a similar ability to adapt and learn, but also bluntly not blow the whole thing up and ruin what it's capable of achieving for them? What's the sort of the human side of this that you find yourself teaching and training and working on with your clients?
Yeah, that's another really good question. Like I said, there's some uneasiness with AI. I remember a guy, in the early days of the company saying to me, because we were integrating our AI system with their building management system, sometimes referred to as BMS, the acronym, right? And he says to me, I'm not sure everybody wants to have AI in their BMS. It's kind of a worry, right? So part of it is just making it clear to everyone, all the stakeholders, that the people are in control of the AI and not the other way around. So the manual overrides and all the protective behaviors and everything else, that's all there for them to be, for the operator to be in control of the AI and not have the AI be, its own completely autonomous thing. It's important to train people, to provide good training and to teach them how things work. But the other thing that we've really learned over the years is that, so our concept now is that, the operator is the pilot of their system, right? And the AI is there to help, to make it, make things work better, more efficient, but they're the pilot. But the reality is that the operator isn't like a person who's there all the time forever, right? People come and go in these organizations. And so even after you train them and you retrain them, they still come and go, and you get people who come in that aren't really that familiar. And so what we do for our customers is tell them that, look, you're the pilot, it's your system, we teach you how to do it, it's got all these behaviors that keep it safe, but we can be the co-pilot, because Vigilent is really good at looking at these systems and sort of looking over the customer's shoulder. And when we do that, it gives them a level of comfort. They have the experts looking over their shoulder, making sure everything's right. And in doing that, we're actually then training them all the time. So it's that expert with the operator interaction that I think is important for AI systems to be comfortably adopted by people that are running, mission critical processes, whether it's a data center or, a refinery or whatever it might be, right? It's important, I think, that, that there be an expert in the background able to help out and provide assistance and, keep people comfortable with the AI.
So once something's embedded and it's kind of up and running, I really enjoyed some of the points and the stories that you shared in our prep call about then what some of the challenges or questions or uncertainties are. So tell us a little bit about, like, what are some of the classic things that come up once this is up and running that you're then further having to educate or work with a client around to ensure that they're comfortable?
Well, there's some sort of interesting and funny examples, right? So, one of the basic things that a Vigilent system does in a data center is it just turns stuff off that doesn't need to be on. And, we might come into a place that's been running along for 10 years with way more stuff running than needs to run because there hasn't been good visibility. And like I said, it's a complicated system. And maybe, you got a room with 40 big, noisy, power hungry machines and they just run them all because that works, um, and then our software comes in and it's super smart and it's looking at everything minute by minute and figuring out what really needs to run and what doesn't, and it turns a bunch of stuff off. And we've had kind of interesting, and these are like legit concerns, like somebody runs into the room, where's the Vigilent guy? And right here, it's too quiet in there. So just the change in the operating condition from how it had been to how it can be when it's really running smoothly it's kind of a shock to people, honestly. And when they see that, they had been running 20 or 40 machines and now they're only running 10, they just, honestly, some of them can't believe it even when they see it with their own eyes. And I've had some customers or their their agents, like, their building management system vendor or something like that, say, nah, this is never going to work, and this is crazy, you shouldn't do this. And I convince the customer to do it anyways. And then afterwards, that agent says to me, if I hadn't seen it with my own two eyes, I wouldn't have believed it was possible. So it's it's the concern that that it won't work. And then even when they do see it work, it's such a dramatic change from how things have been that it's a shock. Yeah.
Yeah. I can totally imagine that, all of us, right, we get used to the way we do things because that's the way we were told to do things. And then you
Right.
have an intelligent system that is then making different decisions, things that
Yeah.
they don't initially logically make sense to you. I imagine that must take a
It
fairly,
takes some time to get used to. Yeah. And another concern, and this is a concern you've heard a lot about AI systems in general, and not even just in industry, right? AI is being used in the legal industry and lots of places, right? And there's a big concern about AI making people redundant, right? It's going to take their jobs. And I mean, honestly, that may happen in some industries, but in the data center industry and in a lot of other industries, it's hard to find good people, and finding people is limiting, the growth and the health of the industry. And so I think really what the effect of making people more productive with AI in the data industry is just simply allowing the data center industry to serve its customers without running into major constraints.
well,
But there is that concern. There are a lot of people in the industry who and in other industries, right, in other process industries, who I imagine are concerned that AI is going to make them redundant. Yeah.
Yeah, and that is also what comes up again in the press a lot. In any
Yeah.
article about it, it's going to be
Right.
referenced.
Yeah. I think there's less of that though, especially in industrial areas. It's simply making people available to do things that, the robot can't do. And there's a lot of that needs to get done that the robot can't do.
So we've kind of identified that there's the energy savings piece, obviously, therefore the CO2 piece. There's
Yep.
productivity, better use of the assets that people have. Are there any
Right.
other kind of benefits that clients tend to either be surprised by or didn't expect to have such an impact?
Yeah, well, so the energy savings is related to a bunch of the other benefits. Like, if you turn a machine off that doesn't need to run, it's not going to wear out as fast. So reduce wear and tear, less maintenance required, because it isn't running as much or as hard. But that also allows the equipment to last longer. So you get better capital efficiency. And if you're talking about big, expensive machines, there's another environmental benefit there, right? It's the embodied carbon in the machinery that operates, the environments in these places. If you don't have to replace it as often, then you're not creating as much embodied carbon. You're not using the carbon to manufacture that stuff as much as you would have otherwise. And that takes people a while to sort of figure out that they're not going to have to replace their equipment as soon as they thought they would. The AI generates a lot of information that helps them make decisions about that, like what to replace, when to replace it, a lot more intelligently. And so they can do a better job at doing that. What they will typically do is just have somebody kind of do a manual inspection, or maybe look at some maintenance records or whatever. But they don't really look at a lot of detailed machine data in order to figure out which one is working and which isn't working. And so they get that additional benefit. But again, that takes a little bit of time for them to figure out. The data itself helps them, do other things in the data center, like manage the power better, right? And manage the capacity of the equipment they have. We've seen some really interesting examples where the AI exposes the fact that, like say in a data center, you might have 4 data halls. It'll expose the fact that maybe you have way too much equipment in one room and not enough in another room. And so people will start moving capital equipment around in order to, optimize their use of their capital equipment. So asset management at a big asset level, right? And getting better use of their assets, moving their assets around to places where they need them. And yeah, we've had a bunch of examples where people have done that. And that has a pretty big economic impact, right? Because otherwise they would have had to pay for more capital equipment in the room that needed the capital equipment, and they wouldn't have harvested it from the room that already had too much.
Well, let's have a look back at the company then. So you mentioned that you really got going in 2008. So we
Yeah.
are 16 years into your journey at the
Yes. Been a
what
long journey.
what is next? Like, has the vision for the business changed, or are you starting to sense different opportunities? What's sort of on the cards for you in the team?
Well, we started off we started off by building an application that saved energy in facilities that use a lot of energy. And to do that, we had to build a bunch of components to fit underneath the application to support it. So a time series database and a web interface. And once we had the web interface, then customers start asking for different visualizations and reports and all these other features. So we started off with an application that had a very specific purpose focused on energy. And we evolved that into a platform, a data platform, right? And now that it's a platform, it can support lots of other applications. It can support other applications in data centers like power monitoring. That's super important to understand where the power is going, where you can add another server, in your racks so that the power system can actually support them. But it also gives us the opportunity to start thinking about, adjacent verticals that are kind of similar, to what we're doing, but not exactly the same. So we've actually gone back to our, original vertical of the big office type buildings, but in a different way. But the platform allows us to do that, to relaunch that old application from way back in the day, but do it in a more modern way. There's all kinds of new analytics that we can run on the platform. So we're basically started with sort of a point solution for a specific problem, but that point solution required a bunch of stuff under the hood that is now expanded into a platform that allows us now to have many point solutions, and not just in the main vertical that we're in, but in others. So we could move into other industries potentially, and take the same AI approach that we take in, data centers, and take that into other industries that have similar problems.
And when you think back, so 2008, it was you, your wife, your brother. What's the team size now? And is scaling team, is that part of the plan, or is it, what do you envisage for yourself?
Yeah, so we have about 40 people now. It's, the data center industry is all over the world, and so is Vigilent. We have systems installed in 26 countries around the globe. Those 40 people are distributed in 6 different countries. So it's a scaling problem in terms of addressing more and more opportunity. The data center industry itself is growing very fast relative to other areas of the built environment. Like office buildings grow at sort of, the rate of the population. The data center industry is growing way faster than that. So sort of keeping up with the industry. So yeah, hiring people is a challenge, because we have to hire people in, for those of us in California, far-flung parts of the world, Southeast Asia and the Middle East, Europe, and so on. And so because our system has evolved from an application into a platform with many more applications possible, we're seeing huge opportunities for growth. And I think that, it's likely we're going to have to maybe raise some more money. We've been self-funded for the past 6 years, but things are taking off to the point where, probably an additional infusion of cash is going to be necessary, I think.
Okay, well, look, thank you, Cliff. I really appreciate you talking to us, not just because it's, about AI, because I do feel it's a concept where we all have this level of familiarity that makes us feel we know way more than we actually do about how those applications work. So I really appreciate you walking us through that, but also I'm very interested to hear where Vigilent grows to, 26 countries and counting. Interesting to hear what comes next. So thank you very much.
Thank you, Alex.
At Jano Media, we recognise that great content has the power to create impactful and positive change for lives and society. Whether that's video, live streams, photography or podcasts, partnering with us will enable you to harness the power of content to engage, inform and inspire. Reach out to us today.